My name is James Herring. I'm a global black belt, data and AI at Microsoft. And today we're going to be covering a beta exam called, 776, which is the Perform Big Data Engineering on Microsoft Cloud Services. If you heard part of the conversation, this is very similar to 475 and parts of 473 as well. So some of the session takeaways. Really want you to be able to review the requirements. If you go to the Microsoft site and look at the exam requirements, this is going to be based along the same lines. I got a little bit deeper with the detail on what the exam folks that were required to provide the details of it actually were given. So you can take this exam. It's in beta. You won't get a grade for it till 6 to 12 weeks after the exam goes public, out of beta. So that can be frustrating. So if you want to wait, it might be, if you need to have the answer, if you passed or not, probably want to wait till it comes out of beta. I also want to relate practical knowledge to the objectives for 776. And hopefully you can come away from this and be able to create an action plan to prepare for the exam and some additional resources as well. So this certification is intended for candidates who design analytic solutions and build operationalized solutions on Azure. Now, that doesn't mean that when we say on Azure, we're talking about a hybrid, bringing it from a source to Azure. If you start from Azure, there's going to be some pieces of this that may not make a lot of sense when we're talking about Event Hub or IoT Hub, that kind of stuff. Data Factory will still come into play as well. But it's really for folks that have relevant work experience in data engineering and can handle issues with SQL Server Data Warehouse. A lot of this stuff from SQL Data Warehouse came from 473 and probably expanded a bit in this exam if you haven't taken those. Azure Data Lake, you're probably going to see some really interesting stuff since we allowed Data Lake to be able to query with Polybase through SQL Data Warehouse as well. So that's something to keep in mind. Candidates are familiar with the features and capabilities of batch data processing. So we're talking like a Lambda architecture where we may have a batch-based system where we may have data that's streaming, that's short supply, and then reporting on that. Operationalization is important with this exam as well. And then candidates of this exam can apply Microsoft Cloud ecosystem to designs, implement big data analytics. So the exam basics, there's 40 to 60 questions on this. It's going to take you 1 to 3 hours. This is probably one of the more administrative type of exams where it covers a very broad set of topics related to big data. Big data is a broad brush, as most of you, if you've used it in Azure, know. You can review the questions for most question types. And I say with most question types, if it's a scenario-based question, you'll be able to review it to the point that you click next. You'll get prompted that says you can't now go back after this point. You click OK. Those are locked in. Now the scenario-based questions, how many of you have taken exams before? Okay, so y'all have seen the little 8.5 by 11 piece of paper they laminate and give to you, and then they give you a Sharpie that's just way too big to take notes with, right? So keep that in mind. If you take 475 or this exam, you're probably going to fill up the front and back of that piece of paper with the first scenario-based question, and they will not give you additional sheets of paper to take notes. So keep that in mind, be very concise, write small, and then you'll probably get up to 15 to 17 questions that will be specific to that scenario, and then you'll be able to click next and go forward. You can have up to 4 scenario-based questions. I've seen 2 on this one. I've seen 2 on 475. Actually, 475, last time I took it, I only saw 1. But it had 15 questions with it. So keep that in mind. It can include up to 20 different types of questions. And that's important. These are adaptive. So if you struggle in some area, say around HD Insight or SQL Data Warehouse, you can see more questions specific to those specific subjects. 700 is a passing score. You don't have points deducted, points are added. You're given points for correct questions. And don't be surprised, I've seen in some cases where I get to a 3rd section and there is no 4th section. So it's adaptive again. So sometimes you can get out of it quickly. So, sorry. So the first section is design and implement complex event processing by using Azure Stream Analytics. Again, this came directly from the guidance that was given from the team that writes the thing to the product group. So when we're talking about ingesting data for real-time processing, always, before you go to an exam, I know this is in beta, but if you study for an exam like this, make sure you go to the site where it actually says pay for the exam or take the exam, and it'll say $165 or whatever it is. There'll be a document in there that says latest changes, and it'll show you the revision date. I recommend for study purposes to actually take that document, click on the link, open it. It'll be basically a PDF, and it'll have strike-throughs with anything that's been removed, and then anything they append to it be written in red text as well. Take that document, go through it, and copy and paste, go to the Azure site documentation, and put your bookmarks for each one of those subjects and break it down into very usable pieces. I think that's the best way to prep for these. And then set time on your calendar, of course. I think that goes without saying. And, you know, just like work-life balance, it's up to you to set that time aside. So next, it's a design partitioning scheme and select mechanisms for partitioning. This could be something like Cosmos DB. It could be with the, actually, since we're talking about stream processing, it's not specific to that. Actually, I'll show you what it is. We've got the partitions, and I'll show you here in a second again. With the stream analytics, that's where the partitioning comes in, the different types. Be aware of that. Ingest and process data from a Twitter stream. Who's not done an ingestion from Twitter yet? Anybody? It's gotten pretty old. It's not hard. Download RapidMiner or do it with this. It's pretty straightforward to do. Keep in mind, depending on which versions you use of the Twitter API, it's going to work or not. But you'll see at least samples that are questioned about that. Connect to stream processing entities. This is pretty broad brush, and it's growing with the types of entities you can connect to. We're talking about IoT, SQL Server, a data management gateway, that kind of stuff. And then estimate throughput, latency needs, job footprint, and then, of course, design reference data streams. So when we talk about the Azure Stream Analytics usage pattern, this is where we've got the event production, where we've got applications, devices, legacy IoT, IP-capable devices that are either Windows or Linux, low-power devices that are taking data and they're feeding it into collection areas. So that's where you've got the cloud gateways with the web APIs that are exposing them, and you've got field gateways that are maybe communicating back and forth, right? So if I have an IoT hub, then I can push data back to that, maybe reprogram it, send it a flag that it's been received, versus an event hub, which is kind of a one-way stream. So be aware of the different types of hubs that are out there with that. With the blobs, you can use blobs for a destination for a number of things. If you haven't played with them, they're much powerful than they sound. It's a web HDFS with a blob store. And the difference between the blobs and data lake, I'll tell you, is converging. A blob, with it being web HDFS, is a container-based system. And basically what changes in that as you create new containers underneath a container is you're extending the file path to that. So blobs are a powerful piece in that. If you're doing NoSQL, understand that if you're doing a NoSQL database, then you may want to use a table type of blob versus a block blob, which you may take a database backup and throw it in. Understand the differences with the file sizes, the total files that can be contained within that as well. But that's all part of the stream ingestion. And then, of course, reference data. When we're talking about stream analytics, you have the ability to consume data in an IoT hub and then go back to reference data. So you may do a lookup if you're talking about something like a toll booth and you want to put the data in the right type of context. And then, of course, from stream analytics, understand that you can do machine learning on top of that as well. And then, of course, the storage and batch analytics. This is all about event hubs, storage queues, topics. SQL DB is going to be in that. Storage blobs and tables are always going to be in that. Document DB, which should be Cosmos DB now. I didn't catch that. They changed this right after the deck came out. So, have you played with Cosmos DB? It's pretty impressive, the stuff that Rima and her team are doing. Follow her on LinkedIn, Rima Nimi. It's Nehme. You can shoot me an email. She's awesome to follow on LinkedIn because she is constantly putting articles out there about how to use and consume Cosmos DB. But the stuff they're doing with partitions, with HA, with resiliency and everything else in Cosmos DB is just amazing. And a little bit about her is that she's a PhD that came from the original team that did Polybase. And if you know anything about Polybase, Polybase is an impressive engine that allows us to query blob store as well as data lake store. And if you're on premise with a SQL 2016, 2017 box, you can actually connect to a Hadoop cluster, be it Cloudera, Hortonworks, Linux, or Windows-based. So it's a very good tool to use. I recommend it highly since I came from that team too. But it's actually pretty impressive, and it changes the way you look at how you load data into a data warehouse for sure. Because a lot of times when we have data, say we got something coming from SAP, they may create a Z table for us with ABAP, right? They create a very similar structure. They create the same structure every time, right? So what we're doing is taking those files, and it may be, say, like a file that's basically just, sorry, I lost my train of thought. We can have a decomposed file that's basically unstructured in a way that it's got all of our fact tables and dimension tables into a single file, right? So with that, we can load it into a blob storage or into a data lake, and then we can write queries directly against that are views to our SQL data warehouse or our SQL server, and then we can update that with a CTAS statement very quickly. When we're talking about data lake, I'm going to show you some code here that's in the slides. I don't actually have any demos for this because they typically don't work during these types of events, but I do have a code in here that you can see it. And then, of course, with the devices, the presentation in action, understand how Power BI can actually take stream analytics and you can see data that's batch versus data that's actually moving and in flight while it's happening. A great scenario, I think, that I like as well with data lake, data store, blob store, is that when you have data that's coming in, you have a book and bill and ordering system that's coming into play. A lot of folks want to get to real-time processing with their data warehouse. And there's a reason that we do batch-based processing in a lot of financial systems, typically because people tend to enter orders incorrectly. They may fat finger it. And you don't want to be the guy that's running to your executive saying, hey, we just got $1 million order, only to find out it was backed out at 5 p.m. because they realized that they ordered something for $1 million when they meant to enter $1,000, right? So nightly processing will reverse that order, enter a correct order into it, and it'll bounce out the next day. Now, in-flight data, we still have the ability with Polybase and Data Lake and Blob Store to have that in-flight data, that $1 million order come in, and we can see it still in the dashboards, the Power BI dashboards that are out there, and they can still make some decisions based on that. They can still do some what-if analysis. It's still available. It's just not going to persist overnight, right? So it's volatile. Just understand that. When we talk about a trade-off spectrum, this is going to be something that you want to understand as well, especially when we're talking about stream analytics, Spark, and Storm for HD Insight. Have you guys played with HD Insight? Jupyter Notebooks, all that stuff? Pretty cool stuff, right? Not really, no? To me, a lot of this stuff, especially when it's in practice, it's good for the exam because it shows the broad breadth of the different technologies you're going to touch, especially when we're talking about big data. But when you're talking to customers, or if you are a customer and you're making a business decision on it, make sure that you apply some type of pro and con type thing, right? Do a matrix, say what's good about SQL Server versus Hadoop, what's not good about SQL Server versus Hadoop. If all of a sudden I have to take all my developers and teach them Java, and they're T-SQL folks and C# folks, not that you can't do C# against Hadoop, you can, but does it make sense, right? So make sure that you take that kind of issue into consideration. You don't want to have half your development staff walk off because you've adopted an open source code that they don't want to learn. Developers, how many developers in the room? Anybody? Okay. How many new languages do you like to learn a year? Yeah, it's not a good thing, right? So understand that, you know, when you have the greatest simplicity with the lowest total cost of ownership, you lose some flexibility and control with that. When you have full control, it's exactly what it means. When we're talking about like an IaaS versus a PaaS or a SaaS, SaaS is great, right? Because SaaS can be ramped up quickly, very low maintenance, and I can do like serverless, right? I can do functions and Lambda functions and stuff like that and get a lot of work done quickly. But I lose some flexibility with that as well. When I want maximum control though, my operational expenditures may go up as well. So when we talk about PaaS versus IaaS, IaaS is going to be a very similar in nature to operational expenditures, right? I'm going to still need a DBA, I'm still going to need a sysadmin, that kind of stuff, whereas PaaS, you know, the DBA can still be utilized, but he's going to be focused more on optimizing all the queries that are coming in, he's a true DBA again at that point. He's not a sysadmin too. Also understand that the control piece of that, when you do a PaaS with HT Insight and stuff, we've got a 3x9 SLA, right? So that's important because a lot of IT organizations, at the end of the day, can they provide you internally with a 5x9 or a 3x9 type of scenario? And SLAs, you guys do have SLAs within your orgs, right? Have y'all read them, what the RPO and RTO stuff is? It's a long process to set up, right? Unless you're in banking and finance where you have a continuity plan, you actually have to do it every 6 months by federal regulations. You probably haven't seen plate spin and all the fun stuff that we do to actually do that. So this kind of takes all that out of the way. But from the exam piece, just understand that there is a trade-off with some of this technology. And I hit the wrong button. So we talked about the ingest process from Twitter string. This is just straightforward, basic, simple stuff, right? You've got a Twitter feed that's coming in, Azure Event Hub that's sitting there gathering the data. And then if you want to see in-flight data, you can use Stream Analytics, feed it straight to Power BI. Now, the advantage is if you're looking for some type of machine learning algorithm, understand with the exam and ignore the Microsoft Confidential. I didn't take that off, that was my bad. It's on the master deck, and this was from Tech Ready as well. So the machine learning piece actually can take the data, apply an algorithm to it, and tell you whether or not there's a certain event happening, yes or no, right? It's like just a simple piece to feed into that. And then you can categorize that in the Power BI as well. Have you guys used Power BI? Power BI is actually pretty cool. It's one of the more intuitive tools I've used in a long time. I don't sell it or anything. It's lipstick on a pig for a data architect, right? So the Azure Stream Analytics differentiators understand the differences between the programmer productivity with declarative-like SQL language. So know that you can have multiple SQL statements in the stream, and you can have where, and you can have simple SQL inside. It's not SQLite, it's SQL-like. So there's a difference, right? Because SQLite is a open source language, and it's used in Azure as well. This is SQL-like. It's closer to Transact SQL, but it is not a full functioning SQL, and I wish we would stop that, but it is what it is. Understand the built-in temporal semantics as well, and I'll show you a thing with that as well in a second. Ease of getting started. It is pretty straightforward to set up a Stream Analytics piece if you've not done it. Do you guys all have Azure accounts? MSDN type, 150 hours of stuff? Yeah, set it up. It's great. Because you can do some really cool stuff with this. Even if it's just, well, I would recommend if you haven't done it, go to the Cortana Intelligence Suite gallery and check out the vehicle telemetry demo. And what that's going to do is spin up a Hadoop cluster, HD Insight cluster. Keep in mind, that's not cheap, right? So you want to make sure you use an ARM template or something and power that sucker off first chance you get. But it also has a simulator. If you're a car guy like me, it will actually spin out like OBD2 onboard diagnostic equipment from a machine or multiple machines and feed it straight to a blob store. And then it'll also ingest it in Stream Analytics, and then you build a Power BI dashboard with the guidance of this tool, and it will show you real-time statistics as well as batch-based stuff that's coming in. And it also has a machine learning piece that's tied into it. So if you build that, you understand that demo, this exam is going to be a little bit simpler, I think, to you. Also understand that it's got a very lowest cost of TCO with some of this other features that are in there. It's a fully managed service, so there is no server, there is no IaaS, there's nothing to manage from your end. It has seamless scalability, just like Data Lake Store, Cosmos DB, that kind of stuff. And it's usage-based pricing, so if you don't use it, you don't get charged for it. Again, HD Insight, if you've used it, is not a usage-based. If it's powered up, you're paying for it. SQL Data Warehouse, if you've not played with it, recommend that you look at the pause functionality as well as the scale out, because you can scale that thing up to what we would have called APS and PDW. We could scale up to 6 full racks physically of 1U servers and a 42U rack system, which would give us 56 compute nodes of compute power. That's 56 U's of compute power with dual Xeons, 2x 8-way procs. Very powerful, over 1.5 petabytes of memory in it. So very powerful system. And what we have in SQL Data Warehouse is you can take a slider, or you can use T-SQL or PowerShell and basically do the same thing. But you don't have to buy all the equipment up front. That's a big plus, right? And then when you're not using it, you can pause it. By using Polybase, you can do aggregation, send that data to Data Lake Store or Blob Store, and your users, when it's paused, can still use Power BI to actually query that. So the point is that if you understand the consumption-based models with this, and you understand how to architect those for, I guess, the lowest cost of ownership, it's important, right? So when you're talking about Stream Analytics versus something like Apache Storm, there's a lot less code to write. This is a simple portion of Apache Storm code. I think when I looked at it initially, they talked about all these hundreds of lines of code to do the same thing. It's not actually hundreds of lines of code, but it's a lot of code compared to 3 lines of SQL that you write in Stream Analytics. So it's pretty good with that. Design and implement Azure Stream Analytics. You want to be able to configure thresholds. You want to use the machine learning UDFs. These are new, so make sure that if you don't understand them, that you go through the walkthroughs. One of the things that a lot of folks don't know, all of our documentation for any of our products, including SQL Server 2016, is in Azure. So go to Azure, go to documentation, look on the specific technology, and make sure that you look for walkthroughs, because most of these have walkthroughs. If you need architectural guidance on how to set these things up, there's an architecture tab, and it has some really good stuff out there about how to deploy in different scenarios. So I would recommend that you look at that as well. You're going to want to be able to create alerts based on conditions. This is Azure. If you're using Data Factory and that kind of stuff, it's a workflow system. It's not an SSI or an ETL tool. It's an orchestration engine. So you have full data lineage, you have capabilities, and they released some new updates to it this week that's making it even better. If you used it 2.5, 3 years ago, take a look at it again. It's changed a lot. So you guys like JSON? So it's all JSON based in there, the ARM templates, all that stuff. Very powerful. Use the machine learning model for scoring. You don't have to know how to build machine learning models here. You need to know how to instantiate them, right? You just need to know how to use it with that. And then retrain a model, it's kind of the same thing for continuous learning. If you've got data that's coming in over time and you want to improve the process of the model, make it accurate, more accurate. Be careful though, I shouldn't say be careful. If you're doing this independent of the exam, make sure that you don't overfit a model, just like you would with any other type of model. Because if your data is coming from a specific source, say if you're monitoring IoT type data and you have some type of sensor that's messed up that's coming into that, you want your machine learning in this case to actually be able to do like pre-failure analysis, like PFA type stuff. So make sure you don't overfit it for that kind of stuff if you do build them. And then use common stream processing scenarios. Now this is an example of an Azure machine learning UDF. And you can see it's just, this is a RESTful API with a put, I'm thinking, yeah. So nothing really, I put the API key here and then replace the key there. Make sure that you always, if you're using like a cognitive service in this case, I think I'm pretty using, yes. Make sure that you subscribe to the services that you try to use, otherwise you're going to get errors and it's going to be a nightmare to track. So make sure you put your API key and its other key there. So when we talk about the use machine learning model for scoring, I've actually got one of the walkthroughs here where it actually talks about uploading a CSV to a blob store, and then you add sentiment analytics from a cognitive service to it. If you haven't done any of the cognitive services, I'd encourage you to check them out. They're pretty powerful, they're pretty nice. It's fun to build your own APIs and data science stuff. If you haven't done the data science track, you'll know what I mean, or if you have done it, you'll know what I mean. But check the Microsoft Professional Programs out on edx.org because you can actually build these and then use them in this type of model as well. But this particular one, it's using sentiment analysis with it, and then you deploy the model as a web service in a machine learning workspace. So this is one where you'll go to the Cortana Intelligence Gallery, basically check it out, and then deploy it on your own workspace. And then you'll create a stream analytics job that calls a web service as a function that'll grab the sentiment for the text input, and then you'll start it and observe the output. So that's what this walkthrough would do. And it's pretty straightforward and simple, honestly. You're not having to write anything, you're just deploying it at the end. Next is implement and manage the streaming pipeline, stream data to a live dashboard. This is as straightforward as it gets. It's not actually collecting any data, it's just connecting directly to it. And then at the end, you'll archive the data as a storage artifact for batch processing. Again, a Lambda type architecture where you have that batch layer, you have the streaming layer. You're going to stream it directly to the Power BI, and then you're going to take the batch layer and then later do aggregations, that kind of stuff. Understand pass-through queries using the into clause. That's part of the tool as well. And then enable consistency between stream processing and batch processing logic. That goes without saying. And apparently I did put Cosmos DB in this piece, so maybe I just missed the first one. Understand the trade-offs between Cosmos DB and Azure Stream Analytics. Apologies for the acronym there. If you're not familiar with Microsoft, we live and die by acronyms. You're going to want to understand the query real-time data by using Azure Stream Analytics query language. Again, this is redundant, but redundancy is key with the Microsoft certification exam. Repeating the same thing over and over again, going through the walkthroughs and getting it. If you haven't taken a measure up exam, when this one comes out, traditionally I will do the study and then I'll get a measure up because we can get vouchers for those as well. The exam measure up exam is creepily similar to the actual exam. If you've not taken a Microsoft exam and you have an old CRT sitting at home, I would say take the measure up on one of those because one of the things inside Microsoft, we have the benefit that we get vouchers for the exams, but we always tell the architects when you're going to take a certification, and yes, we are required to maintain certifications now, anybody that's a technical role at Microsoft. And we tell folks to go to the place that you're going to take the exam at, fail it, learn about the environmental variables, because they are important. I made the mistake the first time I took a new exam. Hadn't taken one since 1998 before that. And I practiced on 3 27-inch monitors. That was a huge mistake because I get to the testing center and it's like literally an 11, 12-inch screen and I couldn't see anything. I had to pan left, right, just to see the question, and then same thing for the answers, and it was very frustrating. So if you know those environmental variables, you can actually scope out a few places. I would recommend going and checking out a few places, testing centers if you have them available. One at a community college might be better than one that draws blood right beside your test. Been to those too. So check them out before you go. And know that if you go in there with your wallet, your keys, take 2 forms of identification, they're going to lock everything in a locker. You're not going to be able to take anything with you. So set that time aside for the exam as well. If you take it here, they'll take it as well, I'm pretty sure, but it's not as bad as, I think, a local testing center. And I'm sure they have some type of legal thing that they're just trying to cover their ends. Be able to identify the query language elements, control query windowing. And if you haven't seen windowing, I'll show you a sample in a minute. There's 3 types in here currently. So we've got tumbling. You'll want to understand tumbling. You'll want to understand hopping. And you'll want to understand sliding. Now when we talk about the tumbling piece, if you look at the last set of contacts, that's where you'll be able to see that you can set an interval of 10 seconds, right? And it's going to tumble. If you look at the timeline, that's how it's going to work with that. So you've also got a group by time zone in this case, which is important. The next piece that you're going to have is the hopping window. In this case, it's saying give me the count of tweets over the last 10 seconds every 5 seconds. So you can see that the syntax is similar. It's actually the same, almost the same. One's by time zone, one's by topic, but the hopping window is also with 10 seconds with 5-second intervals. And then finally, we've got the sliding window. This is saying give me the count of tweets for all the topics which are tweeted more than 10 times in the last 10 seconds. So you have to be careful with some of the windowing. Make sure that you're specific with the queries, but understand the different types when you're talking about the exam. They're close, they're similar in a lot of ways, and you'll just want to make sure that you read the question and know what response they're looking for with that. Always read the questions on the exam. If you're a skimmer, go directly to the question and then go back to what the actual scenario is. That's how I do it, and it's usually better because then I know what I'm looking for in the scenario. Because some of these questions, the scenarios that they set up before they actually ask a question could be a paragraph or 2 long. They can be a bit, they're architectural or something. Next question is design and implement analytics by using Azure Data Lake. Data Lake's one of my favorite things. It used to be one of my most hated things, but I've come to love it. Know that Data Lake is in HDFS, that it's a PaaS offering as well. It comes out of the box encrypted. It has a lot of pieces to it, but when you're talking about setting it up and configuring, it's very easy to set up, but you want to know how to create an Azure Data Lake Store account. So know the difference between Azure Data Lake Store, ADLS, and Azure Data Lake Analytics, which would be the USQL piece. Not just USQL, but some other pieces as well. Next, you'll want to know how to copy data to Azure Data Lake Store, and I say ADLS just for store. I should just say Azure Data Lake. And then secure data with Azure Data Lake via access control. This is important. We'll dig into that a little bit more. Then leverage end user or service-to-service authentication appropriately. I didn't see anything that was huge on this section other than knowing how to setting up the data lake and use it. When we're talking about tuning the performance of Azure Data Lake, make sure that you look at how you're using Data Lake. If it's a primary store for, say, HD Insight, there are some optimizations that you can do, even in Data Lake as well as Blob Store. And that's where you want to look at the architectural guidance in setting up those. And they do impact the performance in Azure, I assure you. Even though Data Lake is an HDFS, you can still have a lot of performance issues if it's not configured properly. And then access the diagnostic logs as well. So when you create an Azure Data Lake Store account, you can use a number of methods. PowerShell, for instance. This is just a simple out-of-the-box demo, setting up the store account, you specify the root directory, creating a new directory within it. So Data Lake, the difference with it, it's not container-based, but if you've ever seen HDFS from the real world and actually navigated through a Hadoop cluster, when it shards data into it, it's not very pretty. Data Lake kind of puts a little pretty look onto it, kind of a Windows-based folder look and feel on it. If you get the chance and you consume data from Data Lake Store and you're using a clustered column store index within a SQL data warehouse, have some fun. CTAS that data back to the data lake and look at the data, how it comes out then. Then you'll be impressed with what it's doing underneath the covers, and you'll be able to understand what I mean when you're taking flat files and just throwing them in a container or a folder and then writing one select statement on top of it to aggregate all that data. It's really cool. It can change completely how you do ETL type of operations for sure, or ELT in this case. So CTAS is like a select into if you're not familiar. It's a create table as select. It's a distributed type of thing. So if you're worked with Netezza, Exadata, I think Exadata, Teradata for sure, and APS, we all use the same type of syntax with that. So copying data to Azure Data Lake Store. This is just simple. It's kind of like AZ copy, except there's ADL copy. If you wanted to have a nightmare, you should have saw Data Lake when we didn't have ADL copy. It was a bit of a pain to move it. So with DistCP, that's another way to do it on the Hadoop cluster, built-in functions as well as a scoop import. I think ADL copy is probably your best bet unless you're a big Linux guy, and then you may want to use DistCP for that. And scoop, who's used scoop here? Performance is awesome, right? I'm kidding, sarcasm. Performance is not that great in Scoop. Secure data with Azure Data Lake via access control. This can be a little bit cumbersome and complicated. I think what you're going to see is on the exam is you're probably going to see, you may see a diagram like this where you have to fill in the blanks with a drop down. Just know that. When you have a question that's multi-part, and you'll probably see a lot of code type examples on this, you're going to be asked to replace at least two variables within the piece of code. If you get one wrong, the question's not going to get a point. It all has to be right and has to be in the right order, of course. So there is no partial credit for that. It's not a 2-point question. I would love to see us actually say how many points a question is worth. It would reduce a lot of my angst when I'm taking an exam myself, but it's important. So this just talks about, again, Azure Data Lake implements access control model that derives from HDFS. This, in turn, uses POSIX. So POSIX is kind of cool. I think I'm pronouncing that right. That's how I pronounce it. It's kind of cool because it doesn't inherit child dependencies. So if you're really worried about, say, you spin up a Hadoop cluster and you're using Data Lake as your primary store, you may have a lot of stream data coming in, you may have a lot of flat files coming into that. And then you may use the Hadoop cluster for the heavy lifting of, say, transformation, ELT in this case. Now, when you take that ELT type of process and you aggregate it, you may write and create new folders. Ideally, you'll have a container that's already created, a folder that's created, that will be connected to your SQL data warehouse or SQL server. So if they write queries up against that, or if you have a view on top of that and they do a select from it, it'll be empty until your job is processed. At that point, then the data will start populating as your job runs. The cool thing about it is they don't have access to that raw data. They have access to that one container, that one folder. And if you create a folder that's underneath that, they don't inherit permissions. You have to physically grant them access to that. Now, this isn't Kerberos at this point. If you want to do Kerberos currently with Hadoop, HD Insight, or if you want to implement Ranger, I should say, on HD Insight, then you have to use a script, you have to be whitelisted, you have to have a certificate. It's somewhat archaic currently, but it's getting better. They've got a plan to fix it. Unfortunately, the guy is out on maternity leave right now. so he's not doing it right now. For tuning the performance, you'll want to know, at least review the different pieces for tuning guidance on MapReduce, HDI, Azure Data Lake Store, tuning guidance on Storm. Unless, I probably wouldn't focus so much on the MapReduce. MapReduce is, I mean, everyone uses yarn engines and that kind of stuff. I think more, I don't see a lot of people, I haven't seen anybody write MapReduce code in production in quite some time since we were doing HD Insight on-premise at Microsoft, which has been a couple of years. You want to know guidance for Spark, definitely, because I think Spark is probably one of the hotter ones still, and it's going to continue to evolve. Interactive Hive, if you see guidance on that, definitely look at that. Kafka is in preview as well as Interactive Hive. You're not going to see questions that are specific until they actually go public, and then it'll probably be a quarter after that. The funding for these exams is currently 2 years. They'll be updated every 3 months. That's the guidance. Now, with that said, I can tell you that the 475 exam dropped from 4 sections to 3 sections, and you will still see the Measure Up prep exam includes all 4 sections. So the actual exam, I think you will just see it will grade for 3 sections now. The last time I took it, it just graded for 3, even though the prep looked just like 4. So the dates for that, there have been no changes that have been publicly made on this exam yet. Again, this guidance I'm giving you is the entire guidance the product groups are given. With the diagnostics, use the blades with this. If you can, understand the blades. You will see blade type. And when I say blades, I'm talking about the Azure blades with the navigation. Understand that there's more than one way to get to a point. So if you're trying to configure a firewall, there's more than one way to get to the firewall configuration settings with the blades. It's not always direct or always clear. But this shows an example of how to process and analyze the data logs in here. And this is just really knowing how to enable the diagnostic logs within here. And know the locations and types and the structures as well. With the Azure Data Lake Analytics, that will be part of this as well. You're going to create an Azure Data Lake Analytics account. It is separate from Azure Data Lake Storage, so they are 2 different pieces. Again, compute and storage are always separated in most of our MPP systems. You want to know how to manage the sources, data sources, the users. You'll want to be able to manage and troubleshoot jobs. In this case, we're talking about SQL jobs in this. You want to know the diagnostic logs. I would probably focus more on the vertexes in here, using the vertex views with the jobs and the optimization. And know that you can execute them locally within Visual Studio, and then you can scale them as they get into the Azure Data Lake Analytics thing. I can tell you, if you've not used, have you guys done SQL at all? There's a mixed bag of opinions on SQL. I like it. I like it because I can implement a C# library where I can encrypt data or I can decrypt it for specific use cases. There are some places where you're doing aggregations and trying to do different steps with the data where it has some hurdles. But for what it's doing, I think it does a fairly good job, and it's improving. So the same type of thing, PowerShell for setting up an Azure Data Lake account. I don't think you're going to see in any case a full feature set like this on the exam. You may see a section like where the second # is there. I think I got a laser here. Yeah. So up here, you may see this section right here, and you'll be asked to replace maybe a location or what the PowerShell function itself is, like new Azure resource group. Always make sure that you read which function it's actually executing because you will see it's, again, not trying to trick you on these exams. They're just testing your knowledge. And you will see RM with some of these. In some cases where you won't see it with the other, know which one it is. Manage, monitor, and troubleshoot jobs. kind of the same thing. You're going to see one section of this with a question, and then you're going to be able to, you're going to select 2 to 3 options that are correct in that. You won't be physically writing code. You'll just be doing drop boxes to complete the code section. So it's not that hard. Yes? Yes. They will. What you'll do is you'll be asked a question that may be a couple sentences or a paragraph long. And then, or it could just be a straight question. Configure properly from, you want to create a Azure Data Lake account name ADLA1, and you want to use this resource group 3. So in that, you're going to see like the script written out for you, and you're going to see 2 drop-down boxes, or 3, and you're going to be able to populate where that goes properly. And you'll probably see the same options plus 1 or 2. Like if you're configuring a firewall, for instance, you're going to see the configure firewall rule, and you're going to see an inbound address, you're going to see the public address, and you're going to see the firewall rule name in most cases. And it's going to give you what it told you, bless you, what it's going to show you is the outbound address, the inbound address, and then in the answer, you're going to put the name, and you're going to select 0.0.0.0, 0.0.0.0. So it's not a trick question. It's making sure that you understand that when you configure a firewall rule, it's just routing it internally to that. So it's not that bad. It's like a multiple choice in most cases. Same thing with knowing how to access the diagnostic logs. In this deck, I've got a sample to actually not, this will show you how to enable it, but this example actually shows you how to analyze and process the logs as well. So I put those links in the decks, and I'll make sure to remove all the Microsoft confidential stuff so nobody's worried about that. No secrets here. The vertexes, understand the vertex view. I don't know why they're called vertex. I mean, next we're going to call them vertices and everything else. So with this is going to show you the vertex execution view, know the locations and types, and understand the structures, what each one of them means. Straightforward stuff when you get into it and start studying. Go through the walkthroughs. Go through the walkthroughs a few times. Take the exam. I think you're going to find that it's a breeze when you get to that piece. When you're talking about configuring files and that kind of stuff, it's really not that bad at all. Now, this is again where, excuse me, you're going to have pieces on the exam where you're going to have to do some USQL, bite the bullet, and understand what you're doing. And this exam can be broad-reaching on the extract and transform data with the USQL. There could be several versions of the exam, which pieces you get, and again, it's adaptive as well. So you're going to want to know how to schematize data. So what I would say is, that, again, if you go to the exam site where you sign up for it, if there's a change to it, or make the list, it's going to show you each one of these sections and the details. And take, I usually create a prep guide as well, where I'll take all these and put links in Azure to it. But I haven't done this one yet because it's still, in beta, it's not really that useful at this point until they change it. But you're going to want to be able to know, major differences between T-SQL and U-SQL, because there are similarities. Understand the case sensitivity with it. Understand C# expressions, with null, equal null, equal null. What do you guys call that in C#? Is there a term for equals? Do y'all have a certain term for that? Like in Access, we used to call an exclamation point a bang, right? I don't know if they still do that. So understand, the joins with pivot, unpivot, cross apply, all that kind of stuff. It's not really a SQL quiz. It's just making sure that you understand the difference. And there's a good likelihood that you're going to see a question that has a SQL syntax when it's expecting to see the equals versus a pound equal, or an equal pound, or an equal sign. So you may see something like that in the drop downs. Understand extending the USQL programmability. This really gets to calling Python, R, and cognitive services type of capabilities within that. Again, USQL, you have the ability to call USQL and execute all this with R or Python or whatever you're comfortable with. You're going to see this improve probably even before the exam is fully released with the data science workbench. All that's in Python currently, so it's kind of different. You're going to want to understand how to perform federated queries with Azure Blob Storage, Microsoft SQL Server, and virtual machines, Azure SQL Database, and Azure Data Warehouse. I would focus more on some of the data warehouse stuff because it's going to make more sense when we're talking about USQL. But there is an Azure SQL Database. If you've not used USQL or Azure Data Lake Analytics, you can create a database on the fly there. Inside of it, it's really kind of neat. And then share data and code access across Azure Data Lake Analytics and Azure Data Lake Store. User-defined functions, aggregators, and operators. I think you're probably going to see a few questions about this, but I don't think it's going to go into any depth at on this level of exam. It's a broad brush stroke exam again, but the adaptive nature of it, if you miss one, it may actually dig a little bit deeper into that. And then, of course, integrate Azure Data Lake Analytics with other services. Ingesting data from Azure SQL Data Warehouse, again, I think that's probably going to be a bigger one, as well as HD Insight. I think when we're talking about catalog, event hubs, data factory, it's good to know how to do that, but I don't think you're going to see anything that's specific that's going to really trip you up. But if you're talking about ingesting data from SQL Data Warehouse, it may be a little bit trickier, and you may have to have the security pieces set up for that. And then my favorite part, if you haven't noticed, SQL Data Warehouse solutions. Design tables in Azure SQL Data Warehouse. Who hasn't touched SQL Data Warehouse, doesn't know what it is? Anybody? No? Okay, good. So as we all know that this is a cloud-born architecture, as much as people like to say that it was PDW or APS based. This has a tighter code base to SQL Server than any of those ever did. I can tell you from experience, I was with PDW when it was version 1. Before that, I worked with all the Data Allegro folks as well, which was a Postgres type engine. But you're going to want to know how to choose the optimal distribution engine. I would suggest also in practice that you keep up to date on Azure. One of the things I do is go to the top right-hand corner in Azure regularly, and I do a search for updates. And if you do that, you're going to see a product updates page, and you're going to be able to select each product of Azure, SQL Data Warehouse if you want, and you're going to see the latest updates, and you're going to see the updates by month, and you're going to see specific updates to that. So identity, for instance, or round robin, or replicated tables, which was a very recent feature, which was badly needed. You're going to want to understand what's supported and what's not when you're doing this in practice, because it's going to change how you approach this. But you're going to want to know how to choose, something with a distribution column to optimize workflows, right? Something with a high cardinality value that you're going to want to put into it. You're going to want to definitely be able to select the proper table geometry. Notice this says round robin and hash. Now we have replicated, thank goodness. But you're going to want to know when to use round robin versus hash versus replicated tables. And you also want to know how to look at the skew of the data and the process skew through the appropriate selection of distributed columns. So if you're familiar with some of the DBCCs, make sure that you understand that the DBCCs, or the database consistency checks in PDW, are a little bit different from SQL Server. So if you have DBCC show space used in APS and SQL Data Warehouse, they are DBCC PDW show space used. So we do carry some of the functions over. And what that's going to do is it's going to show you all the distributions with the row counts, sizes, and that kind of stuff. Column store index, clustered column store indexes, I should have put CCIs. There's no science. This isn't SQL Server, so there's no science to design clustered column store indexes. When you create, know the syntax difference between SQL Server, if you must, and SQL Data Warehouse or APS. When you create a table, you say with distribution equal replicate, round robin, or hash with an ID, and then you put with, comma, clustered column store index. That is the syntax for creating a clustered column store index. But what you're going to want to know really is when does it make sense to use a clustered column store index. I would say lead with a clustered column store index unless you're loading data into it and you want to do a heap. But just know that it's going to default to a clustered column store index in most cases. And then identify when to scale up compute nodes. Now, some of this is a swag. If you're trying to do a baseline and it asks you, you guys know what swag means, right? It's not like an archaic term. Scientific wild ass guess. Take a stab, swag. Okay. Take a swag at it, but we typically start as a baseline of if it's a terabyte, start with the number of data warehouse workload units or DWUs per terabyte. So if it's 1 terabyte, we'll say start with 100 DWUs. Now I can tell you from experience and practice, 100 DWUs is probably not going to cut it for a terabyte. But that's where we start adjusting it because we can adjust the DWUs with a slider, and if you're not aware, the 6,000 DW limitation is no longer around. It's up to 18,000 DWUs because we have traditionally separated compute from storage, but there's going to be some localized compute as well. So there's still 60 distributions. That doesn't change, but the DWUs, the in-memory piece will change. So that's important to understand. But the distributions for a given workload, yeah, I don't know why they have that, because if you're doing a distribution, there are only 60 distributions. So when you're talking about distributing the optimal distribution column to optimize workflows, you know, it's a single column when you create the table. It's not really rocket science. It's if you're a Kimball-esque shop or even an Inman shop, if you're familiar with data warehousing, what you're going to want to focus on is keeping your data local, right, as much as you can. When we're talking about massively parallel processing, we're talking about shared nothing architectures. So we create these 60 distributions, and then we shard the data with the distribution key. So if we have a fact table, in this case, that's going to have billions or trillions of records in it, it's going to be terabytes in size, we're going to distribute that based on something with a high cardinality value. And the whole goal is to make sure that that data is sharded evenly across those 60 distributions. Now when we replicate, that's where we take something like an outrigger table, a XREF table, in a kind of an Inman shop, or a dimension table in a Kimball shop, and we're going to replicate that. And believe it or not, if you do the math and you do the DBCCs and look at the sizes, with compression on a clustered column store index, you're probably still going to save space from your SQL Server data warehouse or SQL Server on SQL Data Warehouse, even though it's going to have copies of it on every distribution. Now the advantage of this is that when the query engine actually receives the query, it's going to execute those independently. So when you're looking at aligning your distribution columns, what you want to make sure that it doesn't have to do is go to another compute node to pull data for a fact table to answer the results of a query, right? So we want to make sure that we use execution plans, and when we look at the execution plans, that we don't have things like partition move or shuffle move, and we can eliminate those by doing a simple, basically a temporary table to clean it up. And you can take a query from minutes to seconds or sub-seconds in that case. So it's just understanding that. Practice with it, look at some of the structures. There's a lot of text on this now. If you want to look at specific people to read, Matt Usher is always a good one. He's with the product group. He's been with it since it was Data Allegro, very sharp guy. He's a good one. James Serra posts regularly. If you don't know James Serra, he's been blogging forever. And he's a good guy too, he's funny. He used to be on the team as well. Now he's just an evangelist, not just an evangelist, he's an evangelist on that team. He was really unhappy when we brought him on board and he lost his MVP status, by the way. So if you see him, rib him about his MVP status. takeaway from this is a distribution column. Candidate is a column without nulls, right? So if it has nulls in it, it can't be a candidate key, right? It's just not possible. That goes without saying. Yes? I mean, if it's designed properly, you know, you can always have a semantic layer on top of it where you can give all of your business analysts or your power users, say, a semantic view of the world, right, where it's got friendly business names and that kind of stuff. What I would recommend, depending on the number of people that you're looking at, because we have concurrency limitations. It's currently 32, it's getting ready to expand double with that. But if you look like someone at Netezza, they have a limitation of like 20 concurrent slots. And we do have a little bit more, but it's no different than it is from SQL Server. It doesn't mean that you can't have thousands of users, because the whole idea of MPP is first in, first out. But when, like if you were to go to a data warehouse that's a terabyte, and in S&P world, it's a shared everything, right? Shared memory, shared disk, shared CPU. And when a user comes in, requests a query, say they want to look for an orphan record that has no dimension key in it. If you were to do that, you're probably going to bring production down, because it's going to take forever doing the scans and pull disk and everything else. With SQL Data Warehouse, that query can execute on the fly. It can happen in seconds with 10, I've seen it with 10 terabytes with 1.5 trillion records in the fact table, and it took me less than a second to do it. So the idea is that, yes, they can do that, but if they're doing really crazy what-if stuff, create a semantic model, give them their own space to use it in. Use a CTAS statement, right? But outside of that, if they're just really doing analysis for a dimensional model that you're sharing, we do have a PaaS offering for analysis services. But typically, just like you would with Teradata or Netezza, those guys, it's a very small number of people that are physically in there, typically, right? It's processes that are going, loading data into it, and then you're exposing it through other tools like Power BI or Click, Tableau, whatever, but they're hitting typically some type of semantic layer at that, Cognos, right? A physically separate semantic layer, yes. Analysis services, for instance. But you can create views on top of that that can be shared. Now, one thing to keep in mind is you can't do cross-database queries within SQL Data Warehouse. And you also can't do recursive CTEs, right? If you have 60 distribution and you have a recursion maximum of 32, you break in the first recursion. So you can't do things like that, but what you can do is, like I said, CTAS it into a separate schema for them, and they can play with it all day long. And the CTAS, the data, what's cool about it is when you've got your distribution set up and you CTAS and copy the data into the same structure, it's very fast, because physically it's not moving it to any other disks. It's all staying within the same compute nodes and everything else. Now when they query it, that's where you can actually give them a resource class that may give them a little bit more horsepower, but you can always crank up the ELT jobs to have the maximum horsepower with the resources class. So there's different resource classes. You're going to want to know that within this exam as well. And that's going to be changing a little bit going forward, but that's how you manage like precedence and memory and how much asset they have when they're doing it. Oop. Did I answer your question though? You think so? I know several customers that have some pretty heavy lifting going on in it. Without any problems, but it's not always best if they're, it depends on the analyst and if they know what they're doing, right? Oh no, you can, you're fine. When you're talking about table geometry again, hash distributed, understand the difference between round robin and replicated as well. A round robin was typically used, it was introduced with SQL Data Warehouse because we didn't have it with APS or PDW. It was basically if you didn't know, if you didn't have something that had a high cardinality value and you just needed to get it distributed, It just basically, like a deck of cards and a dealer table, just shuffled the data out as it came in. Now this creates a lot of shuffle moves on the back end, which can affect performance dramatically. But the guidance for a replicated table has always been, with compression, if it's less than 5 gig, replicate it. Now, you got to take that with a little bit of science too, or a little bit of common sense, that if it's a factless fact table, say a customer dimension, it's truly a fact table. It's not a dimension, and you don't want it replicated. You want that distributed, because it's going to have a lot of data, and it's going to do better distributed across those 60 distributions. So you don't want to copy that. Now, keep in mind, as a SQL, as a data warehouse tool, this is not a transactional system. This is not designed for OLTP, right? If you do an update on this system, you are going to be sorely disappointed with the performance. Because if you have a replicated table and you update it, it's going to have to go and update 60 tables just for one single insert or update. Now, we do upserts and that kind of stuff during the ELT, but what's recommended is typically, like if you're doing delta analysis for an incremental load, we have a lot of customers that do full trunk and reloads of data regularly, in fact, daily. And that full trunk and reload of their data warehouse could have 20 to 30 years of data, maybe more. So what we've been able to do, and they can't change it because they've got so much history built into it, and they need to be able to restate and relook at all that history each time. So what we'll do is we'll basically CTAS it into another operation, and then do a left join and do some type of delta analysis so we can create a delta process for them. Believe it or not, it actually helps in probably 90% of the cases. There's not a one-size-fits-all for that, but you do need to be able to understand how these different types of table geometry structures work. The distributed columns, you know, this is definitely something that you want to look at, right? These are basic rules for most type of candidate keys for atomicity, that kind of stuff. It doesn't define, and keep in mind this is agnostic to whether you're Kimball, Inman, or a hybrid. We support third normal form as well, so don't get tricked if you see anything that's completely dimensional and as a hard fast. I don't think you'll see anything like that on it, but you do want to be able to identify what's a good candidate, I think. So design clustered column store indexes, I thought it included it, but you can see there is no designing a clustered column store index, right? Your design level should be really creating it on a table object and then using a DBCC to make sure it's actually being utilized. Know when you do have a clustered column store index when it needs to be updated. It's always good when you load data into SQL Data Warehouse to either CTAS, and then when you're done with the CTAS or the update option, to update statistics. Now, when you're talking about updating statistics, make sure that you update the right rows. There are some rules that apply to that. They're all in the documentation. But when you do the with clustered column store index, it's going to put a clustered column store index on it. This one particularly, you see the distribution equals replicated. That's just telling it's a replicated table. Now, if you need to create this as a distributed table, you would just say distribution equal, and this is the cool part about it, right? This is write it to disk once and then look at it different ways every time. So if I were a power user, a business analyst, or an architect, and I want to look at a better table geometry, then I can actually say distribution equals hash, or hash, and then I would put my column ID. So it's pretty straightforward. And then round robin would just be distribution equal round underscore robin. It's not case sensitive with SQL Data Warehouse, so it's not like SQL with that. There are some caveats with the data types that are supported. Again, this has more parity than APS does because it's built on the 2016 SQL core engine. So you're going to see like honestly, some data types that shouldn't be in a data warehouse. I don't think we have image, but you're not going to see decimal. You'll see numeric. You're not going to see, we'll see unique identifier, but you won't see, or you'll see identity, but you won't see a unique identifier yet. I don't think. And this is where this stuff can change monthly. So make sure that as a practitioner that you at least check out that or subscribe to it and look at some of the blogs. The team blogs on Azure are, I think, exceptional compared to what they used to be with the other product offerings we had. So it's much easier to get it. Query data in Azure SQL Data Warehouse. You're going to be able to implement query labels. These are very useful in SQL Data Warehouse because when you do start looking at the queries that are running and you run the same query or a CTAS over and over again, it's good that you can actually see in the query tool that what your query is because, like I said, it's a very fast system, and if you have hundreds of queries coming in, your query that's been run for a long time could be on the 12th page, and by the time you get to it, it's already done. So make sure that you understand that. Aggregate functions, just like most SQL Server tools, create, manage statistics and distributed tables. Again, that's the update stats or create stats. There's code that's out there on the web. If you look at, like, it's, again, Matt Usher's and some of the blogs that are out there. We've got a lot of sample stuff that's on APS and PDW. There's a lot of PowerShell stuff that's talking about loading the data. You know, when you're loading data, that Polybase is the fastest way to load data. Yes, you can use, and I'll probably cover this as well, you can use bulk insert, you can use SSIS, and if you use SSIS, make sure you use the latest management pack from that, because what it's going to do is it's going to have you identify in a task the blob store that you're using, the table that you want to create, and the SQL Data Warehouse you're connected to. And what it's going to do is use AZ copy behind the scenes to copy that data into the blob store, and then it's going to CTAS it right to the data warehouse. So it reduces a few steps that you can do. In this, so this is just showing a query label. If you look, it just says option label equals your query label. And then when you're looking for that label, you can say your where clause where it's looking for the label. Straightforward stuff. And that's using a DMV here, system PDW execute request. The statistics, again, like I said, create statistics. It's straightforward stuff. And this is just a create statistics piece. I think this will probably be the easiest part on the exam myself, but I think it makes more sense. Changing resource class is straightforward too. Just keep in mind that it's going to use the largest resource class available. So if you change your resource class from a small resource class to an extra large resource class for, say, an ETL job or an ELT job, make sure that you change it back at the end of the job. Because the cool thing is if you're executing a script or a store procedure, you can have it change the resource class at the start of store procedure. You got your commit statement, and then you change it back to a small resource class so it doesn't hog that memory. Because if you look at the amount of memory, the DWUs, once you hit 1,000 DWUs, it kind of maxes out. You'll see until it gets to 2,000 DWUs. But because this is linear when we're talking about scaling, you need to double the size of the DWUs in order to get linear scalability. That just goes without saying. Let's see. I think we're about done. I think we're about out of time anyway. Understand how to integrate Azure SQL Data Warehouse. This is really where you talk about the scope credential and that kind of stuff, setting it up for connecting to Blob Store, WASB, or Azure Data Lake. You're not going to be able to connect, I don't think, anytime soon. You can connect to SQL Server now from Polybase 2. Expect some performance pieces with that sometimes, depending on how your SQL Server is configured and what's being leveraged. And then migrating to SQL Data Warehouse. You may see a question that came from 473. How do you migrate data from your local PostgreSQL database to SQL Data Warehouse? BCP is your friend in some of those cases, right? Or if they're using Teradata, they may be using Golden Gate, right? Use tools that are going to basically give you text files is the easiest way. It's not a trick, it's just the way it is. This is actually some script. If you get this, this will show you how to set up a distributed store to connect. This took me when I set up the OAuth to get the OAuth token and all that stuff. That was probably the toughest part. It took maybe 15 minutes to go through the notes and get it all set up. But once it's done, and it's pretty cool, right? So check that out. And again, remember that POSIX is enabled on the data lake, so you have to grant access to yourself too on the data lake side. This is just continued. But it's actually really cool when you start loading data into a data lake store and querying it with SQL Data Warehouse, and then pushing data from SQL Data Warehouse to data lake store and using it for Hadoop type stuff. And the last piece, Data Factory, everybody's favorite tool. Yes? I'm sorry? Does this have ADF questions? ADF is now in this as well, yes. So you're going to want to be able to look, implement availability by slice, create dataset policies, configure appropriate link server. I don't think you're going to see really complex stuff on this, and I would expect it to change with the releases made this week. So the exam it's going to change, right? Those are all subject to change at any time as we change our technology. So dataset policies, understand what the policies are. There are several policies. You don't have to memorize these policies. Familiarize yourself with them. And also look through the walkthroughs and look which policies are used regularly, right? Which ones are required, which ones aren't. Because you'll see required no, no, required no, no, no. So keep that in mind as well when you look at these. And look at the default values. I think the retry interval is probably something you're going to want to look at. Data delay, typically default value is 0, don't delay it. That kind of stuff. Retry timeout. This is probably a good idea, especially if you have stuff that's waiting or you're getting charged for it retrying and that kind of stuff. With Data Factory, understand copy. You know, there's a wizard for setting this stuff, but at the end there's also JSON and how you can schedule and execute that. And move data to and from Azure SQL Data Warehouse. That's pretty straightforward stuff, honestly. Orchestrate data processing. I don't mean to make light of orchestration. Anybody that's done any data warehouse implementation knows that there's two very struggled parts, which is getting the data into a readable, usable format and applying business rules and where to apply them. So you're talking 70% of a data warehouse project in the ETL and the ELT, and that is help orchestrated with Data Factory. Create alerts, perform a redeploy, use the monitoring tool. These I've got here, where you can actually see the pipeline component. I haven't checked all the changes, but I'm hoping that you don't actually have to create a pipeline before you can see it, which is a traditional thing with Data Factory. But you can see over here the data set, output data set, and the data lineage, if you're familiar with other ETL tools like SSIS, data lineage has always been a big gap, and it's typically something you had to build. With Data Factory, it's probably one of its biggest strengths, is that you have full data lineage, and it can be leveraged. It can be a bit overbearing, too, for some of the traditional SSIS shops, because what do we do with it now? And, of course, manage, maintain, all this stuff. I think there's 5 sections total on this. So some are stronger than others, but some are redundant when we're talking about data lake store, Data Factory, data warehouse. This is really where we're talking about provision and implementing. Stream analytics, I would expect to be kind of an easier section. SQL Data Warehouse a bit easier if you're doing those 2 pieces, where Data Factory, I think, is probably the one I dread the most when I do these things, because they could come from anywhere with that. But you're going to want to know how to integrate services with Azure Active Directory. You're going to know how to use the local security model. Configuring firewalls, straightforward stuff. Like I said, that moved from 473, I believe, to this exam. And it's going to be a configure. You're going to see an inbound. You're going to see a public, and then you're going to see a connection name. And just know how to execute that. I think you have 3 drop downs in that specific one. And when you see the answer, you'll be like, oh, I should have had that. Implement auditing, that's always important because how you implement it, you don't want it to, it's low latency with that. It's also low impact on your systems. And integrate services with Azure Data Factory. There's links in these slides as well, and I think we're actually running over now. So that would be, yeah, the concurrency, elastic scale with Data Warehouse. talking slider, PowerShell, T-SQL, right? Workloads with DMVs, understand the DMVs for sure. And then AZ copy, Storage Explorer, Redgate. Those are ways to get data from a local data warehouse into data, or from a local SQL server into a data warehouse. Tips, just relax. No one's going to beat you up, I hope. Case studies, you can do the case studies that are bottom up or top down. I recommend going through the case studies that are in Azure, the walkthroughs as I call them. When you don't know the answer, eliminate the wrong questions. Mark items for review when you can. With the scenario-based ones, you're not going to be able to mark them for review. Know that. Guessing's better than nothing because you get points for a correct answer. You don't get points deducted. You don't get any points if you don't put anything down. If you've studied for the exam, don't second guess yourself. That goes without saying. And that is it.